In this video, we're going to talk about determining the domain and the range of functions. So, when they ask you to determine the domain, they are trying to ask you to determine the values of x that are going to define a given function. So, for example, in this case, you're trying to think of values that are going to define this function. Okay? Of course, in this function, we don't expect to have any value that is going to make this function to be undefined. But as you'll see in the next questions, there are going to be values of x that can make it to be undefined. In such a case, we exclude such values as not to be part of a domain. Okay, so what is the domain and the range of this function? So the domain is actually, we're trying to determine the x values that are going to make this function defined. Okay, so in this case, we don't have any limitations. Any value of x, whether negative or positive, it can still give us a result. So therefore, we can say our domain in this case can be a set of all real numbers, okay, which you can represent as from negative infinity. This is less than x, then x is less than. So this is in terms of set interval notation. The other way you can say is, you can use this, you say x is a member of real numbers. Okay, so what is the domain in this case? Alright. Now, let's say you've been told that determine the domain, the range of that function. So we are f of x being equal to x squared plus 2. So how do we now determine the range? So the range, you just have to first of all come up with an inverse function. So remember y is equal to x squared plus 2. So our goal in this case is to make now x the subject of this of a formula. So what you're going to have is y minus 2 being equivalent to x squared. So if you make x a subject, it's going to be the root of y minus 2. Okay, so this is now the inverse function of that. Of course, we need, in cases where they've asked you to determine the inverse function, you're supposed to present it in this form. So where there is y, you put x now. But that is not our interest in this video. So let's try now to determine the range. So the range, we are just going to look at it in the point of view just as we determine the domain. So except what we have as our function is the root of y minus 2. So are there any limitations? Is there any value that can make this function to be undefined in terms of the real numbers? Okay, so whenever you have this root of a negative number, it's undefined under real numbers. So when you're talking about functions, we're not interested in complex numbers. So we can say that all the values that are under a square root should either be equal to 0 or greater than 0. So you should say y minus 2 should either be greater than or equal to 0. That's what we want. So we are going to see that y is actually going to be greater than or equal to 2. Alright, so these are the values that we should expect to be under the square root for it to be undefined. So how do you present it now as the range? So you can therefore say your range in this case of that function is going to be, so where there is y, you can put a function itself. So we expect that all the values that you are going to have inside that function are supposed to be greater than or equal to 2. So the minimum value that you have is 2, and all the other results are supposed to be greater than 2. And that makes sense if you look at this function. So you expect that whether you put a negative or a positive number, they are all going to be to give you a positive number at that point. And so the minimum that you can have is when x is equal to 0, and that is your 2. So that makes sense. Now let's say you have the function of x being equal to x plus 1 divided by 2 minus x. I've asked you to determine the domain and the range. So to start with, how do you determine the domain? So think of it in this way. Think of it from a negative point of view. Is there anything that can make a fraction to be undefined? So we all know that a fraction is undefined when you are dividing by a 0. So we should come up with a set of x values that should not give us a 0 on the bottom, on the denominator part. So 2 minus x, therefore, should not be equal to what? Should not be equal to 0. So if you make x to be a subject, you have negative x being not being equal to negative 2. So you divide by the negative on both ends. X is actually not supposed to be equal to 2. So all the other values can work except 2, because if you put 2 where there is x, it is going to be a 0, which is going to make it undefined. So we can therefore say x is a member of real numbers, but x should not be equal to what? Should not be equal to 2. So that's our domain for this function. Okay. How about the range? How do we get to determine the range? So the range in this case is supposed to be dependent on the inverse function. So let's try to make x the subject. So let that part for the function be y. So y is equal to x plus 1 over 2 minus x. So what do we have from there? Can continue from there. So if you cross and multiply, you're going to have y multiplied by 2 minus x being equal to x plus 1. So from there you have 2y after opening brackets minus xy should be equal to x plus 1. So remember, our goal is to make x a subject. So this can go the other side there, and the 1 can go the other side. So we have 2y minus 1 is equal to x plus xy. So making x a subject, we can factorize it and remain with 1 plus y. On this side, we maintain what we have. So from there, we're going to see that we're going to have. So if you divide by on both sides by 1 plus y, because our goal is to make x a subject. So 1 plus y. So your x is therefore equivalent to 2y minus 1 over 1 plus y. So you've come up with an inverse function in terms of y. So let's try to determine now the range. So just like we determined the domain, even the range is supposed to do the same. So when you have a fraction, what your goal is to make sure that you don't have 0 as the denominator, because it is going to make a function to be undefined. So 1 plus y, which is the denominator, should not be equal to 0. So y is therefore not supposed to be equal to negative 1. Okay, so what can we say? We can therefore say that the range f of x, the values that we should expect are, of course, member of all the real numbers, but we expect that the function is never equal to what? Is never equal to negative 1. So there is no value that is going to give us a negative 1 in this function. And this is therefore your range of values. So what is the range? So the range is giving you a set of y values that you should expect in a function that you are given. Okay, so the possible results are all real numbers between negative infinity all the way up to positive infinity, except the function is supposed to skip negative 1. That's what it means. Now let's say you've been given a function 1 plus x squared plus 1. So you can pause the video and try this one out. Alright, so if you look at it as well, it's also a function. So we expect that we shouldn't have a denominator that is equal to 0. So therefore our domain, we expect that x squared plus 1 should not be equal to 0. So x squared should not be equal to negative 1. So that has gone the other side. Okay. So what else can we say? Our goal is to make So our goal is to make x the subject. So x should not be equal to root of -1. So what does that mean? So that means that there's no value that you can put there where there's x squared apart from the root of -1. So, and this is not part of real numbers, it's a complex number. So it being a complex number, so there is no real number that can make that function to be undefined on the denominator part. So we can just therefore say that the domain is a set of all real numbers from -infinity to +infinity. Of course, we use curved brackets. So if you don't know how to present sets using set interval notation, check out for our video on that. Okay, so the other way we can say our x values actually a member of all real numbers. There's no exception. Okay, so what is our domain in this case? So there's no value that you can put where there's x squared to give you a 0 because it has given us a complex number. How then can you find the range of such a function? So like as usual, the range is supposed to first of all make x a subject of a formula. So where there's a function there, we'll put y over x squared plus 1. So you have y x squared plus 1 with cross and multiplied there. So if you make x to be the subject in such a case, so you have to distribute y. So it's going to be y x squared. Let me write that on top. So y x squared plus y equal to 1. So our goal is to make x the subject. So you remain with that on the left. You have 1 minus y. So you divide by y. And your x is going to be the root of 1 minus y over y. So we've come up with the inverse function in terms of y. So we need to look at the values that can make a function to be undefined. So we have a combination of a fraction as well as a square root. So in a square root for real numbers, we shouldn't expect to have a negative number there. And for a fraction, we don't expect y to be equal to 0. So these are some of the restrictions that we have. Y should not be equal to 0. Then 1 minus y as a fraction should be greater than or equal to 0, because we don't want negative numbers there. Okay, so now using the two conditions, let's try to find the values of y that we should expect after plugging in the values of x in that function. So even before solving, if you look at that function, it's 1 over x squared plus 1. So all the values that we are going to put in under x squared, whether positive or negative, they are still going to give us positive numbers. So first of all we should expect are positive numbers. But then the maximum number that you can have should be 0. Should be a 1, sorry. Should be a 1. When x is equal to 0, you have 1 over 1, which is just going to be a 1 as the biggest number that you're going to have. So you have a maximum number to be 1. Again, we don't expect to have negative numbers. So it's just less than 1. So x should be less than 1. Then it's also equal to 1. But then, what is the minimum value that we expect? So do we expect to have 0 in this case? So there is no possibility of having a 0 unless if we add x on top. But in this case, there is no possibility of having the function being equal to 0. But numbers can't go beyond 0. So 0 is less than x, but x is less than or equal to 1. So this is your range that you should expect. So now let's try to determine that by solving, by calculations. Okay, so we have 1 minus y over y. It should be greater than or equal to 0. So what we're trying to solve here is an inequality. So if you've not looked at inequalities already, do well to check out our video on that and you'll be able to understand. Okay, so we solve inequalities equated to 0 by getting the numerator. So 1 minus y should be equal to 0, so that we determine now the distinct points. So making y the subject, y is going to be equal to 1. Okay, so come up with a number line. So you have 1. Okay, another point. What other points can we use? We can use 0 in this case, because we know that there's no possibility of having a 0, so we can use that. So the only possibilities of us so it's either the numbers are between 0 and 1 that can give us a value that is greater than 0, or less than 0 or greater than 1. So I'll start with less than 0, negative 1. So if you plug in negative 1 in this function, what value are you going to have? 1. So we plug in negative 1 over negative 1. So you have 2 over negative 1, which is negative 2. So that value is less than 0. So this part is disqualified. Alright, get a number between 0 and 1. Let's say maybe 1 over 2, 0.5. So you have 1 minus 0.5 over 0.5. So 1 minus 0.5 is 0.5 over 0.5, which is giving us a 1 there. Okay. So this part is giving us a positive number. How about greater than x? Greater than 1, sorry. So if you try maybe 2. 1 minus 2 is negative 1 over 2. It's a negative number. So we don't want that. So we can therefore make a conclusion to say the only numbers that we need, they should be greater than, so our function results should be greater than 0 and should be less than or equal to 1. But 0 is not included. That's why we've not put this there. Now let's say you have f of x being equal to the square root of 1 minus x squared. So they ask you to determine the domain of such a function. How do you determine the domain? So we're saying that whenever you are given a square root, we're supposed to make sure that whatever is below there is supposed to be greater than or equal to 0. We don't want to have a negative number there. So all the numbers that we want are supposed to be greater than or equal to 0 itself. Okay. So how do we solve inequalities? So if you are not so conversant, check a link for a video on inequalities. So whenever you have such an expression there, it's very important that you come up with distinct points. Okay. So let this part be equivalent to 0. So 1 minus x squared being equal to 0. That is possible when so negative x squared is going to be equal to negative 1. So you divide both sides by negative 1. X squared is equal to 1. So our value of x is going to be plus or minus the root of what? 1. So what you have is positive or minus 1. So you come up with a number line. You have negative 1. You have a 1 there. So it's either they are less than, in between, or greater. So those are the possibilities that we should expect. So let's try out and see which values can give us the numbers that are greater than 0. Okay, so I'll start with in between. I'll start with 0. So what happens if I plug in a 0 there? What should I expect? So if I plug in a 0 there, suppose we're going to have 1 minus 0, and the root of that is going to be a 1, which is what we want. So it seems this part has agreed. So meaning that all these other parts are going to refuse. So if you try negative 2, it's going to be 1 minus 4, which is going to be undefined. And the same if you try a 2 on the other side. So the possible values of x that can satisfy this equation are, since we have that part there, it's going to be negative 1 is less than or equal to x, and x is less than or equal to positive 1. So the only values of x that we should expect to define that function are between negative 1 and positive 1. The rest are going to make it undefined.